Hello there, we're going to talk about 6-6 today, and this is solving systems of linear inequalities. So, in 6-5 we just had one linear inequality and we learned how to graph it, and here we're going to have two, sometimes three, and we'll graph both of them, and then the solution of the system will be any point in the area where the shading of your two graphs overlaps. So we have two vocab words. System of linear inequalities is a set of two or more linear inequalities containing two or more variables. And the solution to a system is any ordered pair that satisfies both linear inequalities in the system. So we start out with kind of the easy stuff, same place we started out before, with an ordered pair, and we want to know, is this a solution to the system? And all we have to do is plug x and y into both inequalities and see if it makes them true. So let's do that here. We'd have -3 less than or equal to -3 times -1 plus 1. So -3 less than or equal to 3 plus 1, -3 less than or equal to 4. And that is true. Now let's try the second one. -3 less than 2 times -1 plus 2. So that would be -3 less than -2 plus 2, which is 0. So -3 less than 0, that's also true. So then we have yes, this would be a solution. So it has to be true for both in order for it to be yes, otherwise it's no. Okay, now when we're graphing systems of inequalities, we graph each line and shade. You can see here in this example that where the shading overlaps, which would be in this purple area right here, is the solutions of the system. And so any ordered pair in that shaded region satisfies the system of inequalities. Let's do a couple of these here. We'll start out with this one. So I'm going to graph the first one here. Y is greater than or equal to 3/2 x plus 1. So that has a y-intercept of 1. So I'm going to start at 1 and then a slope of up 3 over 2. Up 3 over 2. And then I draw my line here. And it's going to be a solid line. So there's that line, and since it is greater than or equal to, I shade above. Okay, and then for my second line here, I'm going to start at 3 with a slope of 4, so I go up 4 over 1. And draw my line, and this one's got to be a dashed line because it's just less than. Put my dashed line in here, and it's going to be shaded below because it's less than. So you can see that the blue and the red overlap in this region here. So I'm going to shade in black. Okay, so that region there is the solution of my system. Let's look at another one that's a little bit harder. So you'll notice here that I got one of them that's in slope-intercept form, the other one's not, so I'm going to have to put it into slope-intercept form. But let's graph the first one first. I'm going to start at -7. There's a slope of 1, so I'm going up 1 over 1. And it's just a dashed line here. And it's greater than, so it's going to be shaded above. Okay, now let's solve this other one here for y. So I'm going to have to subtract the 3x. So I get 6y is less than or equal to negative 3x plus 12. And I'm going to divide by 6. So I get y is less than or equal to, this is going to be negative 1/2 when I reduce it, plus 2. So now I'm going to graph that one starting at 2, and going down 1 over 2. And that one's going to be a solid line. And that one is less than or equal to, so it gets shaded below. So you can see, and once again we always want to make our shaded region where they overlap darker. It's right here in this black area that the red and the blue overlap each other. Okay? So any ordered pair in that shaded region is a solution to the system. Now one more here, and I just wanted to show you this one because of the first line. I wanted to remind you that if there's no x in the equation, it's a horizontal line. So if I have y less than or equal to 3, that's going to be a horizontal line at 3. And it's going to be just straight across at 3. And since it's less than or equal to, it gets shaded below. Okay, and then my second line I have start at 5, slope of negative 1. So it's going to be a dashed line coming down. Something like that, and it's greater than, so it gets shaded above. So the region where these two overlap would be right in here. Okay, so if I run into equations like that, just remember that they are horizontal or sometimes vertical lines. Okay, so that's all for part 1. Let me know if you have any questions tomorrow.